So our objective for today is to learn simple and multiple regression using R. We're going to go through this file, okay? And there are several packages that we're going to use, which I'll discuss in a few minutes. Now, when we do simple or multiple regression, whatever the software that we're using, there are certain assumptions that we have to take into consideration. These are the assumptions that are required. Okay, if there are violations of this, then we have to check the model, the linear regression model. First is linearity of the data. When we say linearity of the data, there has to be a linear relationship between our independent variable or predictor variable X and the outcome variable or dependent variable Y. This can be seen by plotting, by creating a scatter plot between X and Y. And if there's no linear relationship between them, then it doesn't make any sense to do a linear regression uh, between X and Y, between your dependent variable Y and your independent variable X. Secondly, there has to be linearity of the parameters. We'll discuss this in a while. When we say linearity of the parameters, the coefficients of our model, the betas, should be linear. So it cannot be non-linear. For example, we cannot, your beta cannot be, it cannot be raised. The beta is not raised to an exponent. I'll explain this in a while. And then third is the residuals. The residuals have to be, they should display homogeneity. When we say homogeneity of residuals, the variance of the residuals should be constant, which we call homoscedasticity. If the variance is not constant, so for example, when we plot the variance, it's increasing over time or decreasing over time, or it follows a certain pattern or a trend, then that indicates that the residuals or our error terms are non-constant as far as variance is concerned, and therefore it will violate the assumption that are needed for linear regression. Okay, so this is a very important assumption. The error term should be homoscedastic, and aside from that, the explanatory variable should not be collinear. What do we mean by this? When we look at the relationship of the explanatory or independent variables, they should not be collinear. Okay. Now, as far as the dependent variable and the independent variable is or are concerned, it's good for them to be collinear. The dependent variable y should be collinear with the independent variable x, because that means that x will be able to uh, explain, or x will be related to y, and that's a requirement for us to have a linear model as far as x and y is concerned. Now also, the residuals should also be independent. Now this is more for time series. Okay, for time series, because the data is arranged chronologically, then we can see if there's a relationship between the chronological residuals. If there's correlation between them, then that will violate also the assumptions of classical linear regression models. And lastly, we have the normality of residuals. The residual errors are assumed to be normally distributed. So these are the assumptions that need to be assessed, that need to be evaluated when we do linear regression model. Okay, so let's continue. These are the packages that we're going to need for this exercise, this activity. We have the psych package, PaceText, OLSRR, Stargazer, SchemR, ggplot, we know, dplyr, oh, sorry, there's a repetition of Stargazer, And then we'll also need performance analytics and JTools. Some of this you have already installed, and some you might not have yet installed, okay? So for those of you who have not installed some of the packages here, kindly install them and then require, okay? So for those of you who have already installed them, may I request you to now load the wage.csv file, okay, which I sent to you, I think over the last weekend. So let's create an object called wage, okay? And then let's read that CSV file. Okay, let's use file.choose. Okay, so I'm going to, so let me load these packages first. And then let's import the data set. So wage.csv. Okay, so as you can see, it's now loaded. I'll give you a minute to install the packages and to load the data. So once you have done that, guys, kindly write here in the chat box that you are already done with the requiring of the data of the packages, and done with the installing, importing of the data set. Thank you. Thank you for your response. Thank you. Okay, let's give a few more seconds to the others. Okay, so let's view the file that we're going to work on. Okay, so notice guys na I already included the codes here kasi wala na tayong time kung if I'm going to ask you to type the codes on your own, no? So pasensya na kayo kung linagay ko na dito, no? Anyway, most of the codes here alam nyo na naman, so may mga bago of course, but a big chunk here you know already. So let's view first our data. So this is our wage data. Okay. So we have, how many variables do we have in this data frame? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 variables. No? Okay, so you have education. This is, there are 526 respondents. So this is US data. I got this from wage data. Sorry, hindi ko nalagay yung source, ano, but this is actual data. So the study is all about determining what influences hourly wage. So if I'm not mistaken, this was in 1980 or 1970 shata, and this is the hourly wage as regards this particular individual who has 11 years of education, 2 years of experience with the company. So work experience shata to, tenure is how long has this individual been with that company, and then race niya kung white, gender, female, civil status, single, number of dependents, 2. Okay, and then the hourly wage that this individual receives is 3.10. Okay, so we'd like to model, we'd like to understand more hourly wage. What are the factors that influence or affect hourly wage? Is education? Could education explain the hourly wage of an individual? How about experience? How about tenure? So does race have something to do with hourly wage? So kapag, ano ba yung mga race natin? White at saka non-white, no? So dito sa survey na to, white at saka non-white, kapag white ka ba, may kinalaman yun sa hourly wage? Or is it gender-centric? Kung male ka ba, may i-influence yung hourly wage mo? Or kung married ka ba, mas malaki dapat yung hourly wage mo? Or is it number of dependents? So in this model, we're going to try to establish the relationship between hourly wage and the other variables. Hourly wage will be our dependent variable here, and education, experience, hanggang number of dependents will be our independent variables. Okay? So we'd like to create a model so that we can explain hourly wage and also predict. So usually guys, dalawa yung rationale, dalawa yung objectives ng regression model. Number one is to be able to explain or describe our data of our variable of interest, which is in this case is hourly wage. Secondly, we'd like to predict, no? I-model natin si hourly wage para ma-predict natin yung magiging hourly wage. Kunyari, kung ang education niya 15 years, experience niya 12, race niya white, etc. Can we predict hourly wage? Or what are the variables that can influence hourly wage or explain hourly wage? So that's that's the objective of creating a regression model. Okay, so balik tayo dito, no? Okay, I won't run any more head at saka tail. Alam na naman natin yan. Okay, alam natin dito yung subsetting, yung wage. Okay, let's just take a look at the structure of wage. So we have here 526 observations, 8 variables, 3 of which are character variables. Okay, yung 1, 2, 3 integers, mga numeric. Okay, yung hourly wage is numeric, no? Yung integer numeric din naman yan. So tatlong character at saka limang numeric variables. Okay, so we can also look at the class. So let's test lang. Ano ba ang class ni education? So si education as shown, integer. Si race naman is character. Okay, so aside from the structure of wage, we can also get the summary of wage. Okay, so sabi natin, itong summary, this is more, dinidescribe sa atin yung 5 number summaries, no? Actually 6, minimum, quartile 1, quartile 2, quartile 3, okay, and then maximum, and then also the mean. Okay, for the character variables, ang ibibigay lang sa atin dito yung count, no? Kung ilan siya. Okay, so we can actually generate descriptive statistics, no? Pwede tayong mag-generate ng descriptive statistics. So sa final assumption, kasi ito yung part ng final assumption, which is also yung may nagtatanong sa akin. Ang final so guys is of course dun sa online at saka isang group finals, no? Para tulungan na lang kayo. Okay, so sa site package, we can use this describe, which will give us descriptive statistics. So if you take a look at that, so ito yung mga variables natin, no? Yung may nakalagay dito na asterisk, these are the character variables. So variable 1 up to 8, number of respondents 526. So ito yung mga yung mga descriptive statistics. Of course, sabi natin walang meaning tong average ng mga categorical variables, no? Okay, standard deviation, median, trimmed median, mean absolute deviation, minimum, maximum, range, okay? And then skewness, kurtosis, and the standard error. Okay? So we won't discuss this anymore because yung mga skewness na to at saka kurtosis na to, this was part of your previous subject. So just recall na lang guys kasi sa paper nyo, sa group paper nyo, kailangan nyo i-discuss kung in general ano yung i-describe nyo yung data nyo. Yung skewed to the right ba yan? Skewed to the left? Okay? Platycortic ba siya? Okay? Leptocortic, etc. Okay, I'll close this. And then there are other descriptive statistics that you can use. Yung paste text, meron siyang yung function na stat.descriptive. Okay, so let's take a look at that. So this is maraming descriptive stat guys sa R. Okay? So for example, ito din, binibigay sa atin yung ilan yung mga NA daw. So may mga not applicable, ibig sabihin walang laman. Okay? Minimum, maximum, range, yung sum. Okay? Although for men, that might not make sense for several of the variables kasi education, but na naman natin i-add yung education. Median, mean, standard error, okay, confidence interval, variance, standard deviation, coefficient of variance, okay, etc. So ito guys yung mga, notice na NA dito sa mga categorical variables. No? So these are your variables. Parang pareho lang siya ng ano ng psych na describe. Only that the difference is that si psych, okay, si psych yung variables nasa row natin, no? Samantalang si pastex, yung stat.descript niya, yung variables niya nasa columns, no? Okay, then we have also, ito guys, yung Stargazer, magandang ano siya, magandang package in R that generates reports in a very good tabular fashion. Kaya nga dun sa ano natin, dun sa materials na binigay ko, ito guys, yung nice output in R, Stargazer. These are materials, ito yun, no? About Stargazer. Using Stargazer to report regression output and descriptive statistics. Okay, so I'm sure you'll be able to understand this already kasi ano lang naman siya, packages lang naman siya. Empty cars, submit na natin dati yan. So you can use this, no? You can go over these materials and see that a Stargazer can generate descriptive statistics or regression outputs in a nice table. Ganun din tong package na to. Okay, this is the documentation for Stargazer. So beautiful LaTeX, HTML, and ASCII2 tables from our statistical output. So may mga examples din dito, no? Okay, which you can use. Okay, these are good materials which you can use guys sa project, no? Sa group project nyo. Actually, group finals, no? Okay, so let's go back here. Okay, so tingnan lang natin to. So here, Stargazer function from the Stargazer package. Okay, ito kailangan guys, type is equal to text. Kasi pag hindi natin inuna yan guys, parang HTML, LaTeX code yung lalabas sa kanya. Okay, so, alright, so tabular form siya guys, maayos, no? Unlike yung dalawa kanina na hindi siya naka-tabular. Okay, you can copy this and you can copy this in Word, so in good form. Okay, digits, linagay ko lang kung ano yung maximum digits niya, 3. Okay, then we can also use the scheme package to generate descriptive statistics. Okay, so why am I showing you how to do descriptive statistics, guys? Because bago tayo mag-regression, kailangan muna intindihin natin yung data natin. Okay, so this is also another way to generate your descriptive statistics. Sa scheme, guys, sa scheme package, so this is, saan ba galing si scheme? Scheme is from the scheme package. Okay, let's just wait here. Okay, so you can see here that, ayan, from scheme R pala, no? This is from the scheme R package. Now, if you were not able to, you know guys, if you were not able to install that package, kahit hindi nyo siya na-install, pwede naman ganito. Okay, yung namespace niya, yung scheme R, mararan pa rin yan, even if the scheme R package has not yet been downloaded. So this is the output, no? Ang maganda sa scheme function, sinasegregate niya guys yung yung character from the numeric. No? So ito yung numeric natin. Okay. So sa character, sinabi niya 3 variables. Okay, and then sa numeric naman, so kino-compute niya guys yung mean, standard deviation. This is the minimum value, yung PO. P25 is the first quartile, second quartile, third quartile. This is the maximum value, and then may ano tayo ng histogram dito para makita natin yung nature ng data na to, no? we can see that these variables are barely really non-normal, no? Not normally distributed. Okay, so let me close this. All right. Now, we're now going to perform a simple linear regression. Pag sinabing simple linear regression, guys, isang independent variable which we're using to try to explain your dependent variable. I had a discussion of this in Excel na naka-video, guys. If you want a more basic discussion, please view that video, guys. Let me show that to you. Ito, no, yung mga video dito, yan. Introduction to regression using Excel. This is simple, and this is multiple. But using Excel and let me just drink. And the add-in Excel real stat. Okay, so this is another video, guys. Okay, so actually yung discussion natin ngayon, meron na tayong ano, I already gave an initial video for that. So I'll post this video also later. So may dalawa kayong pwedeng tingnan na video plus this one, regression diagnostics. Kasi hindi natin matatapos lahat ngayon. So we're going to have this and then hopefully we have more time next Wednesday to do some generalized linear model. Dito na papasok yung logistic regression, okay? And maybe if you have time, probe it, okay? But I'm going to request, guys, on Friday, magkakaroon ako ng discussion para sa lahat ng sections ko sa FINSTAD. You're all invited. I'll post the time. So anyway, I'll also record that so that if you can't attend, then you'll be able to still watch it. Okay, so let's go back to our discussion here. Okay, how do we do regression? Before we do that, guys, maganda i-plot muna natin yung independent variable natin, educ, and our dependent variable, HR wage. Now, dati, ang plotting natin, ggplot2, di ba? So you can do that, no? But you can also do yung quick way, this is from base R, yung plot. Okay? So let's plot this. Let's also learn this. If you plot, the x-axis is education. The y-axis is HR wage. And then the main, we know this, guys, yung title ng plot na to. So if we plot this, okay. All right. Bakit hindi siya nagpa-plot, guys? Why? Because wala tayong educ dito, no? We don't have an educ object or an HR wage object. These are variables from the wage data set, no? So what we should do is to identify kung saan galing yon, no? So dapat ito yon. Wage dollar education, wage dollar lab. Pwede bang hindi ilagay yan, guys? Pwede. Pwede bang hindi ilagay yung wage? Do you recall, guys, kung paano natin, pwede pa natin i-plot kahit na hindi natin ilalagay yung data frame niya? Can anyone recall? Paki-chat? Yes, thank you, Bianca. That's correct, no? Bianca is correct. Attach dapat. Dapat ilalagay natin attach. Okay? So yung function nun, ganito. Let me just show you. Attach. So if we do this, guys, sige, run natin, ha. Attach. Okay, and then i-plot natin to. Okay, yun, nakuha na niya, no? Ibig sabihin, guys, any variable here refers to the wage data frame. So this is good practice, guys, kung isa lang yung data frame natin na ginagamit, no? Kung wala namang ibang data frame, okay lang yan. That saves a lot of time, hindi na tayo magde-define ng wage. Pero kung maraming data frames tayo na ginagamit, that might be quite difficult, no? So, kasi baka magka-problem in, kunyari, may isa kang data frame na ginagamit pa, tapos may pareho silang variable na pangalan kaysa dun sa wage. So, magkakaroon tayo ng problem. Okay? So, if you're done, guys, with the, with the wage data set, no? Pwede mo na i-detach yan. So, ganyan lang yung detach. Okay? All right, but let me go here. Okay, pareho lang naman yan. Kaso nga lang ito mas matagal, guys, ano? Kasi linalagay pa rin natin yung wage. Sorry. But anyway, so let's plot this. Wage, education, wage, hourly wage. Then we gave a label to the x-axis, to the y-axis. Plot character number 20. Ito yung maliliit na dots. Frame is equal to false. Ibig sabihin wag niya lalagyan ng borders. Main is equal to scatter plot. Okay, lagyan natin to. Okay, so we have the same. Okay, pareho lang, ano? Okay. All right, then dito, ang problema natin dito sa frame na to, sa plot na to, hanggang 15 lang yung no? Yung years of education. So extend natin a bit, guys. Let's extend this by i-add natin to, no? Axis 1. Pag sinabi natin 1 dito, it refers to x-axis. And then the function sequence, minimum 0, maximum 20, increments of 5. Okay? So if you want to change the axis of the y-axis, ang gagamitin mo dito 2. Since what we want to change is the x-axis, kasi nga yung plot natin hanggang 15 lang, ano? Sa y-axis wala tayong problema. So let's run this. May axis na dinagdag tayo. Okay, highlight. Run. Okay, so medyo na no? Na-extend na yung x-axis natin. Okay, hanggang 20 na. Okay, so let me close this. Okay, now we can also modify the plot by adding, i-add natin, guys, yung average natin ni wage. So since si wage is on the y-axis, okay, kadalasan, guys, pag nagre-regression, yung dependent variable should be on the y-axis, and then the independent variable will be on the x-axis. So if you notice, guys, kaya nga inuna natin si education dito, kasi ang una dapat dito x-axis, no? Tapos dito y-axis. And then here we're including an AB line, horizontal, H is equal to mean ng HR wage. So let's plot, let's include yung hourly wage, okay, horizontal line, color dark green, line width 2, line type 1, straight line lang to, okay. Ganun din si vertical line, wage education naman, yung average nila, no? So if we plot this, all right, so we have this plot, okay. All right, so this is the average hourly wage. This is the average education. Okay. All right. Now, I'd like to make some comments here. Okay. Pag nag-regression tayo, guys, pag nag-linear regression tayo, what we're trying to model is your dependent variable, which we always put in our y-axis. Okay. Ordinarily, guys, kunyari, kung wala tayong, what if we don't have what if we don't have this years of education? We don't have that data. Paano natin mamamodel si hourly wage? How do we predict hourly wage kung wala tayong independent variable? Kunyari, we don't have this data education. Siyempre, wala tayong plot, no? We cannot have this scatter plot kung wala tayong x-axis, wala tayong predictor variable, which is your x, no? So what do we do? Well, what we can use is the average, no? Average of hourly wage to predict our dependent variable, our hourly wage, no? which in this case is, magkano nga ba yung ano natin? Kunin ko lang dito, mean hourly wage. Dinitouch ko na pala, no? Wage. Okay, so that's 5.9, no? 5.9 yung average hourly wage natin. Okay, so if you're asked to predict how much is the hourly wage, we can use the hourly wage, no? The average 5.9. So kunyari, pinapaano sa atin, pinapa-predict yung hourly wage of any person. So we can say we can predict it to be $5.9. Ano yung basis natin nun? Yung average niya. Ano ginamit natin? CY lang. Si hourly wage lang. But hindi natin ginamit yung mga X ano natin, variables. Ang assumption natin, wala tayo nun. No? Ang assumption natin, hindi tayo nag-survey. So wala tayong age, education, wala tayong number of dependents, wala tayo nun. Okay? So in order to predict our hourly wage, what we can use is just hourly wage itself. Okay? So si ano lang, si Y lang itself. Okay? All right. So let's continue. Now, but we have hourly wage, no? We have the predictors. We have, in fact, 7 independent variables. So we're going to make use of them. Initially, ang gagamitin muna natin is one muna. One muna, guys, and that's education, no? So kapag isa lang ginagamit natin na independent variable, ang tawag natin dyan, simple regression. Okay? But before we do even regression, mas maganda kung kunin natin yung correlation nila. Correlated ba sila, guys? Correlated ba si education at saka si hourly wage? So let's see. Let's compute so dito in-attach ko si wage, ano? So sige, i-attach natin. Attach natin si wage, tapos kunin natin yung correlation ni education at saka ni hourly wage. So what's the correlation? It's 0.41. Okay? So are they correlated? What type is the correlation of our education and hourly wage? The answer is positive, no? Positive yung correlation nila. Ano ibig sabihin ng positive? A positive correlation indicates that the two variables move in the same direction. Ano ibig sabihin ng same direction? Kung tumataas si education, tumataas din si hourly wage. Okay? So ganun yung ibig sabihin nun. Kung bumababa si education, bumababa din si hourly wage. Dali, pause lang ako. Okay? Yeah, thank you, Paul. You're correct. So sabi ni Paul, as the X variable increases, the Y variable increases at the same time. Very good. That's correct. So same direction. Ano naman ibig sabihin, guys, kung negative yung correlation? Opposite direction. Habang yung isa tumataas yung value, yung isa naman bumababa, no? So correlation yun, no? Now, pwede ba to, guys? Correlation ng wage lang? Di ba, guys, si wage, it's a data frame consisting of 5 numerical and 3 categorical variables. So pag rinan natin yan, okay, mag-error tayo. Ang sabi, X must be numeric. Kasi hindi naman natin pwedeng kunin yung correlation ng character variable, no? Yeah, thank you. Yeah. Okay, so may sinabi dito si Paul na there must be 2 variables that must be regarded in solving for correlation. Okay. But in R, guys, pwedeng 2 or more, no? Pwede nating isama lahat ng variables, i-generate niya correlation ng lahat, no? Ng lahat. Of course, by twos lang, by twos. So dito ang gagawin natin, tinanong ulit natin si wage. Ang mga character variables natin dito nasa column 4, 5, 6, no? 1, 2, 3, 4, 5, 6. So ang gagawin natin, pwede nating patanggalin si columns 4, 5, 6. So if you take a look at this code, correlation ng wage, and then isa subset, lahat ng rows, comma, and then ito yung columns, di ba? Negative C, 4 to 6. Ibig sabihin nun, guys, tanggalin si 4 to 6. Okay, remove the categorical variables because we cannot get the correlation of categorical variables. So let's run this. Control Enter. Ayun. Okay, so you can get the correlation. So this is the correlation matrix. So you notice that yung mga mirror image niya, they should be the same. No? Correlation between education and itself is 1. So lahat ng nasa diagonals, guys, lahat yan 1. No? Kasi the correlation of a variable with itself is of course 100% or 1. They're perfectly correlated. By the way, guys, I failed to mention ang correlation, it ranges from -1 to +1. So I'm sure you have met this before. And -1 indicates a perfectly negatively correlated correlation between the two variables. Okay? Ibig sabihin, kung ano yung a 1 unit increase in one will also generate a 1 unit increase in the other and vice versa. No? Okay, I'm sorry, 1 unit increase in one will yield an 1 unit decrease in the other. That's a perfectly perfect negative correlation. Pag perfect positive correlation naman, 1 unit increase sa isa, 1 unit increase din sa isa. Okay, so yung experience with education, negative 0.2995, education with experience, negative 2.2995. Okay, a while ago, I mentioned something about multicollinearity. No? Ang ibig sabihin nun, we don't want the variables to be, the independent variables to be strongly correlated. Ayaw natin yun kasi baka ang problema niyan, guys, pag strongly correlated sila, tapos sinama natin yan parehong regressors, parehong predictors, baka mag-agawan sila in trying to explain your dependent variable. So let's try to see ano ba yung medyo highly correlated dito na na independent variables. 0.05. Wala naman ako nakikita na ang nakikita ko lang tong point this is with hourly wage. Ito. Experience and tenure, guys. Ano ito? Almost 0.5. So si experience at saka si tenure, mildly siya, no? There's a siya yung pinakamalaki among the other independent variables. Now, gusto natin, guys, si hourly wage will be highly correlated with your independent variable. So, okay siya with education. Experience, hindi masyado. Tenure is also relatively high, 0.34. Number of dependents, mababa. No? In fact, negatively correlated siya. No? Okay, so ibig sabihin nito, pag tumataas yung number of dependents, bumababa yung hourly wage niya. Okay, so that's how we interpret yung correlation. No? So bago kayo mag-regression, guys, mag-descriptive statistics muna, analyze yun, tapos mag-correlation. Titingnan natin correlation ng dependent variable with the independent variables. Okay, gusto natin, guys, na si dependent variable highly correlated with your independent variables. Pero ayaw naman natin na si independent variables highly correlated with each other. Ayaw natin nun, no? Kasi magkakaroon tayo ng problema niya ng multicollinearity, which we're going to discuss when we do diagnostics. Okay, now this is another way to show your correlation plot. Ito maganda to from performance analytics. Baka sa Friday, guys, i-discuss ko to kasi as an additional material and quant mode kasi napaka-ganda ng mga packages na yun. Okay, so let's run this. Okay, so let's run this. Okay, again, error, guys, kasi ginamit natin si wage. No? So kailangan, guys, i-define natin si wage dapat hindi kasama yung categorical variables. Method is equal to Pearson. No? Kasi maraming klaseng correlation. May Spearman, may Pearson. So yung ginagamit natin is Pearson. Okay, so let's run this. Okay. So this is a lot better than just the tabular. Okay, let me see kung ano siya. Okay. Okay, let's take a look at this, guys. Okay. Ang kagandahan nito, itong galing sa performance analytics, you have three sets here, no? Unang-una, ito yung histogram ng mga variables natin. So 1, 2, 3, 4, 5, kasama si hourly wage. Okay? So ito yung histogram niya. Okay, then you also see here the scatter plot. Okay, of this is scatter plot education with experience, education with tenure, education with number of dependents, education with HR wage. Okay, on top here, guys, you can see the correlation. No? So ito yung correlation ni education at saka ni experience, negative 0.3. And you can see that here, no? Pababa yung ano, yung trend line nito, no? Okay? Ito naman, guys, 0.5. So this is ano to? Correlation between between tenure and education. Ito 'yan. So medyo flat siya, but they are statistically significant, no? Yung mga tatlong asterisks dito, ibig sabihin statistically significant 'yan. At the point, I think 0.01 confidence level of significance, or 0.001. Ito 0.01, and then pag isang asterisk, 0.05 significance level. The others, guys, are not significant. Ito maliliit, no? Tingnan to, very small. Okay? Very small siya. So they are not significant. Ito 0.05 lang. So hindi significant yung correlation ni education at saka ni tenure. Okay? Education and tenure. Sorry kanina, guys. Sorry. This 0.5 is experience and tenure. Okay? I think I said education and tenure. So mali yun, no? So ito, guys, ang gagawin nyo lang, wherever the box is, kunyari ito, you go just the left side, education, and then you go down, hourly wage. So it tells us that the correlation between education and hourly wage is 0.41, and this is the scatter plot. So if you take a look at this, medyo weak, o medyo medium lang yung correlation ni education at saka ni hourly wage. Now, importante tingnan yan, guys, kasi anyone? Okay. Kasi we're going to do linear modeling, and we want the correlation between your dependent variable hourly wage and your independent variable education to be very strong. No? Gusto natin strongly correlated sila para may capability yung independent variable to explain our dependent variable. Okay, so let me close this. Close ko muna to. All right. So how do we now model? In R, it's very easy, guys. No? Very easy in R. So let's create this model 1. Okay. The function is LM. So this is from base R, linear model. So how do we write it? We first start with the dependent variable hourly wage, and then tilde, okay, and then education. Do you know where to find tilde? It's in the key below escape, upper left, no? Nasa taas ng yung grave accent. Okay, so depending on your keypad. Okay, and then data is equal to wage. Okay, and then this one, guys, if we run the first line, notice may parenthesis dito, no? Yung parenthesis niyan, guys, it will automatically print the output. So let me run that line. Okay, so tingnan nyo, guys, oh, pinapakita kagad yung yung intercept at saka yung slope. Okay, so a more complete output is your summary than mod 1. Notice, guys, meron na tayong object na mod 1 dito. Okay, let's take a look at the output. This is pretty similar to the output in Excel or in Xrealstat. So if you take a look at this one, guys, so it gives us the residuals, no? Yung residuals, ito yung error terms. And then minimum, first quartile, second quartile, third quartile, maximum. Okay? So we find here, guys, ito yung ano natin, no? Ito yung mga coefficients natin, ito yung mga parameters natin. You have intercept and you have the independent variable education. And then you have these values. Okay, intercept negative 0.9, and then you have your education approximately 0.54. And then you have measures of your standard errors. And then this is your t-stat. And then your probability. Okay. Ang tinitingnan natin dito, guys, kung statistically significant yung predictor natin, yung 0.5414, this one. Okay? This is practically, ano to? What's that, guys? So let me copy this. Hindi rin nag-work yung ano ko, yung... Okay, sige, dito na lang. Okay, ano ibig sabihin to, guys? It means 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 1, 6. Okay, yan ang ibig sabihin yan, di ba? This one. So, 3 star, yan ibig sabihin, ano ibig sabihin yan, guys? It is significant at 0.001. Yan, no? 3 stars, significant at 0.001 level. Ibig sabihin, less than 0.001 siya. Pag dalawang star, significant at 0.01. Pag isang star, significant at 0.05. Pag dot lang, significant at 10% level of significance. Okay? Then we have here some measures, no? Residual standard error. So this is your standard error, 3.38. Okay? So this indicates, guys, ang standard deviation ng mga error terms natin. So it's indicative of how far it is from your regression line. No? Gaano kalayo siya from the regression line. So the higher the standard error, the more more inaccurate is your model, or the model is not able to explain your dependent variable. 524 degrees of freedom. Ano ibig sabihin nito, guys? Ano ibig sabihin nito? How did you get this? So that's your DF1. Degree of freedom is equal to n minus k, where n is your number of observations minus predictors. Okay, actually may minus 1 pa. Sorry. Okay, how many observations do we have, guys? How many observations? We have 526, di ba? Okay, thank you. Yes, correct. Thank you, Jasmine. 526 observations, no? And then minus K. Ilang predictors natin? In our case, isa lang yung predictor natin sa education. Kaya nga, simple linear regression lang to, no? So we have 1 predictor. Okay, and then minus 1. Bakit nagma-minus 1? This will account for the lost degree of freedom because we have to estimate also the intercept. Okay, so minus 1. So that's 526 minus 1, that gives you 524. So doon ang galing tong 524 degrees of freedom. Okay, so this one also multiple R squared. Ano ibig sabihin ng multiple R squared, guys? So that's your R squared, which is your coefficient of determination. Okay, I would highly encourage you guys to watch the videos on introduction to regression using Excel kasi doon ine-explain ko yung basics talaga. So, what's the coefficient of determination? Okay, anong inaano nito? Anong in-explain nito? So it tells us the proportion of the variation of the variability of your dependent variable, in this case yung hourly wage, that can be explained by your predictor, which is hourly wage. Okay? So anong ibig sabihin niyan, guys? Si hourly wage, kaya niyang i-explain sorry, mali. This is education. Si education can explain the variability of hourly wage. 16.5% of that. Kaya niya. Ibig sabihin, yung 83.5, hindi niya kaya. Ibig sabihin, it can be explained most probably by other variables. So R squared is an indication of the goodness of your model. Okay? The higher the R squared, generally, the better. It means that your model, that your linear regression model, can explain your dependent variable. Okay? So itong adjusted R squared, explain ko mamaya, no? So anong nangyayari dyan, guys? Pagpadagdag, kasi pwedeng gawin natin na, sige, dagdagan lang natin ng dagdagan yung predictors natin, yung independent variable. Kasi pag dinadagdagan natin, guys, yung independent variables, si X, talagang tataas ng tataas yung R squared natin. And do we want that? Yes. However, may qualifier tayo, no? Hindi lang basta-bastang regressor. Kasi pwede tayong dagdag ng regressor natin, taas ng taas ng multiple R squared, pero yung pala dinadagdag natin, wala naman siyang kinalaman dun sa natin, the independent variable. So the adjusted R squared is a measure in order to penalize, no? Penalize yung mga pagdagdag natin na regressors na hindi naman relevant, no? So pag multiple regression, ang tinitingnan natin sa adjusted R squared rather than the multiple R squared. Okay. So ito, yung huli, si FSTAT, guys, this is for your, ilagay natin dito. We use the FSTAT para sa para sa test statistic for overall goodness of fit test. Okay? So, pag nag-statistical test tayo, syempre meron tayong null hypothesis, no? So, yung null hypothesis natin dito, B0 is equal to B1 is equal to 0. So, what does this mean? Ang sinasabi natin dito, B is 0 is the intercept, B1 is the slope for education. Ang sinasabi natin sa statistic na yan, sa test na yan, na si intercept at saka si B1, they are statistically insignificant. They cannot predict, no? They cannot predict hourly wage. Kaya ang lumalabas sa atin dito, no? Ang value ng FSTAT natin is 103 on, tingnan nyo to 1, okay? So this is your degree of freedom 1, yung number of predictors. Degree of freedom 2, which is the n minus k minus 1, okay? Degree of freedom. And then p-value is, pareho lang nasa taas kanina ito. So that's practically 0, no? So anong conclusion natin, guys? What will be our inference? So if this is your null hypothesis, tapos ang lumabas na FSTAT ito, 103 on 1 and 524 degrees of freedom, p-value is 0.000, etc. Okay, so this is significant at 0.001. Anong conclusion natin? We reject the null hypothesis that B0 is equal to B1 is equal to 0. There is a strong statistical reason to believe that B and B1 are values other than 0. So yan ang conclusion natin, guys, no? May null hypothesis tayo, di ba? Okay? Take note guys, ang ang mga ano natin, ang sa regression, mga hypothesis to, no? In fact, meron tayong dito may hypothesis din tayo dito, no? Okay, so tapusin ko muna to, ha. So dito sa FSTAT na to, ang hypothesis natin B0 is equal to B1 is equal to 0. Okay? So ang inference natin, because P value is less than usually 0.05, no? Since kailangan natin dito, since P, which is equal to lagay ko lang sa 3 decimal places, is less than 0.005. Okay? Okay? Since P is equal to 0.005, which is less than 0.05, which is usually the benchmark, guys, no? Okay, usually ito yung ginagamit natin na level of significance. We reject the null hypothesis that B null is equal to B1 is equal to 0. So reject natin to, no? Ibig sabihin nun that we have strong statistical reason to believe that these values are other than 0. Okay? So may nag-chat, let's check. For all types of data, yes. Yes. Mamaya sa example natin, magkakaroon tayo ng character, no? Sa FSTAT, guys, sa goodness of fit test, take note, this is overall goodness of fit, huh? Okay, this is overall goodness of fit test. Okay. That's for the F statistic. Ito yun, no? Meron naman tayong for the T-stat. So this is now for the individual test of significance for the parameters. Okay. So tinetest din natin guys yung bawat isa nito. Ito yung parameters natin, si intercept at saka si education. So ano yung null hypothesis natin dyan? So sa intercept, ito yung test natin, no? B null is equal to 0. Okay? So, tapos yung isa pa, HO, so I'll call this HO1, HO2, HO3. So what's this telling us, guys? Okay. Ano conclusion natin dito? Notice for the intercept, the probability is 0.19 and this is greater than 0.05. So dito ang inference natin, we fail to reject, no? Dito we fail to reject the null hypothesis. Fail to reject HO. So hindi natin mare-reject to. Okay, there's strong statistical reason to believe that the intercept is equal to 0. Kasi by virtue of the p-value, no? Take note, guys. Remember this. when the p is low, the null must go. Okay, remember this, guys. So, ibig sabihin, guys, dapat alam natin yung null hypothesis for any statistical test. So always identify the null hypothesis and then try to see if the probability, okay, the p-value is less than 0.05 or depende dun sa level of significance na ginagamit. If it's less than 0.05, then we reject the null hypothesis. Okay, take note, di ba? When the p is low, the null must go. Ibig sabihin, reject. So ibig sabihin, ang antithesis yan, kung hindi siya mas mababa dun sa 0.05, which is the usual level of significance na ginagamit, then we will fail to reject the null hypothesis. Okay, how about B1, guys? Si B1, tingnan natin, guys. Tingnan nyo. So, as we mentioned a while ago, this is statistically significant, no? So, okay yung education natin. Okay. So it's a value we know that other than 0. Okay? All right. So let's go here. Now, how do we write now the equation? Ito guys, inline text. No? Nasumulat lang ako. Kaya sa nagkakaproblema, hindi lumalabas yung ano. I-correct nyo na lang guys kung ano yung mali ko dito. Ano ba mali ko dito? Baka may nag-chat. Okay, thank you, Bianca. All right. So, okay, so ito yung equation natin guys, no? I'm not sure why this is not running. No? Hindi siya nagra-run guys. Okay. Ayaw pa rin. Anyway, this is the equation, no? Hourly wage is equal to negative 9.049 plus 0.5414 times education sub I, mga sub I to guys, no? Plus error term sub I. Okay? So, this is our equation guys for hourly wage. Now, bakit natin sinasama si intercept kahit na hindi siya significant? The rule is, guys, kahit na si intercept hindi siya significant, sinasama pa rin natin siya sa model in order to predict education, predict hourly wage. However, guys, kung yung independent variable, in this case, hourly wage, ang hindi significant, then dapat hindi siya isasama, no? Okay? So, if we, okay, balikan natin to, no? Yung R square niya, okay, ito yung sinabi natin kanina, no? 16.5% of the variation of the variability of your dependent variable hourly wage can be explained by our dependent variable education. So, ang kayang i-explain ni education kay hourly wage is 16.5 dun sa variability niya. Okay? Or if we want a higher R squared, higher coefficient of determination, then one of the ways to do that is to include more variables, include more explanatory variables. Now, there are 3 measures that are very important for us. Yung nasa ano din to guys, kaya I strongly encourage you to really watch the video. No? SST, sum of the squares total. SSE, sum of the squares residual. Okay, errors or residuals, and SSR, sum of the squares of your regression. Sa ibang books, guys, medyo naiiba yung ano na to, no? Naiiba yung name niya, no? Yung iba yung residuals, ginagawa nilang SSR. Tapos yung regression, ginagawa nilang E, no? Nagbabaliktad. So just take note of that, no? So this is explained. Sum of the squares explained. Unexplained. Errors. Yung hindi kayang i-explain ng model natin, or ito naman yung explained. Okay, I gave here the formula, guys. Hindi ko lang maintindihan kung bakit hindi siya nagra-run. Okay? Pero tama itong mga ano na to, no? Tama yung mga latex code na to, no? Wide hat, guys, lalagyan lang ng malaking hat si hourly wage. Can you help me, guys, kung bakit hindi kaya nag-inline text, no? Ba't hindi bakit kaya? Tama naman yung ano ko. Dali ha? I might have missed something. Sa inyo ba nagra-run, guys? Thank you, Jasmine. Kay Jasmine nagra-run. How about sa inyo, guys? Oh, okay. Sa akin lang may problema. Okay, good. At least sa inyo, nag-run, guys. Sa akin, hindi. I don't know why. So, okay. It doesn't matter, no? So, may formula tayo ng SST, SSE, at saka SSR. Okay. Si SST, guys, if you take a look at this is the actual data minus the mean, no? Minus the mean of HR. Ito yung sinasabi natin na kung wala tayong independent variables X, pwede natin gamitin lang si dependent variable mismo. Pwede natin kunin yung mean niya yung average niya, tapos kunin natin difference, tapos square natin. Okay, sige. Thank you, Paul. Guys, pag may question kayo, ilagay nyo sa sa lahat para para makita din ng iba, no? Okay. So, there's this question. Ano yung ibig sabihin ng 16.5? Ulitin natin, ha? Itong 16.5, guys, ito yon. Yung R squared natin. Ito siya, no? This one. Itong sa model natin, ito. Multiple R squared, 16.5. Anong ibig sabihin nito? Di ba, we're trying to model hourly wage. Okay? So, si education ba, kaya niyang i-predict or kaya niyang i-explain si hourly wage? Yes. But only up to 16.5%. Okay? So, yung variation, okay, ni hourly wage can be explained by education. No? Up to how many percent? 16.5%. Okay, so yun ang ibig sabihin ng R squared or coefficient of determination. Okay, ang implication niyan, the higher the R squared, the better is your model able to explain your dependent variable. Okay? 16.5%, no? So, of course, hindi lang yun yung magiging basis, guys, kung okay yung model natin. Meron pang iba na explain ko na lang mamaya, no? Okay, did that answer your question? Paul? Okay, thank you. Thank you. All right. So, ito guys, pwede natin makompute si SST. Ibig sabihin nito, sum of the squares total. Okay, notice sum of the squares. Kasi, ini-square yan lahat, no? Okay, sige, copy lang natin to, ha? Can you please copy this? Control C, Control V. What will happen if we just get the sum? Okay. Pwede natin tanggalin yung isa dito. So, ang gawin natin, guys, hindi, kulang pa ng isa. Okay, kulang ng isa. Okay, what am I doing here? Ang ginagawa ko, si hourly wage, okay, here, si hourly wage, ima-minus ko sa mean niya, sa 5.9. Okay? I-minus ko sa 5.9 to, tapos i-sum up ko siya. Ano mangyayari? If we perform this, it's practically zero, guys. No? This is zero. That's why we don't get the sum of your hourly wage of your dependent variable minus the mean. Kasi ang ibibigay lang sa atin yan, zero. Because that's the meaning of mean, guys. Ibig sabihin ng mean, nasa gitna siya. No? Remember, it's a central tendency. It's a central tendency. So, ang ginagawa, we square it. No? Kaya ito, in-square natin, guys. We square it. Tapos, ito naman, guys, si SSR. Ano naman si SSR? Okay, this function fitted will give us the predicted values of model 1. Ano ba yung model 1, guys? Di ba ito yung ano natin? So this is model 1. Okay, ito yung laman ni model 1, di ba? Mga coefficients, residuals. Okay. So these are the elements of, it's a list object. Ito yung mga laman niya. No? Okay, so let me go back here. So we can use the fitted function. Fitted model 1, this will give us, okay, i-run lang natin to. Fitted model 1, so rinan ko siya. Okay, ano nakuha natin? 5.05. What's this, guys? 5.05, balikan nga natin to. Wage. Okay. Ang real value niya, 3.10, hourly wage. Ang model value, ang predicted value is 5.05. So, Kita natin na medyo malayo, no? Pero the fitted value will give us the predicted value. Predicted value. Guys, minus the average, okay, mean ng wage, no? That will give you the explained variance. So that's the sum of the squares of your regression. Ibig sabihin, from the mean, guys, di ba? Yun ang unang model natin. Ginamit natin si education, nagkaroon tayo ng fitted line. Okay? So ibig sabihin, in-improve natin yung ano natin, improve natin. Dati kanina, yung mean lang, 5.9. Across all values of your hourly wage, ang prediction pa rin natin, 5.9. Ito hindi na, guys. Oh. Yan. Ito na yung mga predicted values natin using our model. And then, yung hindi natin nakuha, okay, yung mali, so, kinukuha natin yung difference ng yung predicted value minus the actual value. Ito na yung actual value natin. Then, square natin. Okay? So, dito, we have a relationship between sum of the squares total and sum of the squares residual at saka SSE. Okay? So, let me run this whole chunk. Okay. So, this is now your total variation. Okay? When you compute for the standard deviation or the variance of your hourly wage, okay? Ito yung total, no? With respect to, so this is the actual minus the average. Ito yun. Anong nangyari, guys? Nung nag-fit tayo, gumamit tayo ng linear model, nag-improve yung model natin by 1180. Okay? So, ibig sabihin, out of this total variance na 7160, na-explain ng model natin 1180. Ang hindi na-explain, 59881. Okay? So, if you can see, guys, pag inad natin si SSR at saka si SSE, it's the same as your SST. So, that's the relationship, guys. So, sum of the squares of the regression plus sum of the squares of your error terms is your sum of the squares of your total. And sabi natin, guys, si R squared is simply your, ito yung R squared, 0.165, which is, ilan yung variation na kayang i-explain ng model natin? 1180. Ilan yung total variation? 7160. So kaya nga dinivide natin, guys, no? Ang lumabas sa kanya, ito, 0.165, which is just the same as R squared. Okay? So yung model natin kayang i-explain 16.5% of the variation, no? Of our model. Okay, so this is another way to present model 1. Okay, so this is a good way. Andito, guys, maganda yung pagka-present. Kaysa kanina yung mod 1 lang, yung summary, ano? This is a better way pagka-copy natin to sa Word. Mas maganda to. Okay? Then, si model 1, guys, may mga laman yan, no? May mga laman yan. Let's take a look. Okay, names niya. Ito yung mga laman ni model 1. Coefficients, residuals, etc. Okay, and we saw that a while ago when we clicked model 1 here. If we take a look at model 1 coefficients, ito siya, no? Yung intercept at saka education. And then, si residuals, ito yung mga error terms, no? Ito yung mga error terms. Okay, then we can also look at the confidence interval for model 1. So ito, guys, take note of this, no? Si education, it ranges from 0.4437 to 0.646. Notice, is it possible that this value becomes 0? Hindi. Kasi, yung confidence interval natin, hindi naman tatamaan si 0 eh. Kaya nga sinasabi natin na we reject the null hypothesis that this can be equal to 0. Pero yung intercept, guys, tingnan nyo, negative 2.25 at saka positive 0.441. Pwede bang tamaan yung 0 dito? In between this? Yes. Okay, that's why, kanina sabi natin, we reject the null hypothesis that B sub O is equal to 0 because it's statistically possible that B sub O is equal to 0. Because based on this confidence interval, tatamaan si 0, no? In between this. But nevertheless, sabi natin guys, sinasama pa rin natin si intercept sa model natin. Pero pag ang independent variables guys, pag hindi siya intercept, kunyari sa education, hindi significant, kunyari negative to, tas positive to, then hindi natin pwede magamit si education sa model natin. Okay, I think it's almost time guys. I have, I think, 1 more minute. Okay, you can write the, pakibasa lang to, no? Tapos I request you guys to, pakiplat na lang to. Okay, quickly. Plot ko lang to, no? Okay, so you can see now here, ito yung mean ni, ni HR wage, ito yung mean ni, ni education, and this is our regression line, yung blue line yan. And notice guys, ito, yung regression line will always meet. This point is the intersection of X average and Y average, okay? So si X average at si Y average guys, laging kasama yan dun sa regression line natin. Ito. Okay? Yung mga residuals natin guys, yung mga points na to, yun yung mga red lines yan, di ba? Hindi kasi siya tumama dun sa regression line natin. So mga errors natin yan. Okay? And then last guys, so let's call it a day. Ito lang guys. Okay, you can create okay, so ito na lang. Ito, i-run nyo na lang to, no? We can use the library Broom in order to create an object. Let's call it mod1 diagonal diagnostic.metrics. Okay, augment model 1. Ibig sabihin si model 1, dadagdagan niya, no? Tingnan natin, run natin to. So we now have this mod 1. Okay, tingnan natin. So this is now mod 1 diag.metrics. Tingnan nyo guys, ano nangyari? HR wage, si dependent variable, education, si independent variable, tapos may mga dinagdag sa kanya. No? Ito na yung fitted value. Okay? Ito na yung predicted value natin. Residual, ito na yung error. Kasi ito yung actual value, 3.10. Ito yung predicted value, 5.05. Pag minus mo yan guys, yun ang residual natin. Okay? Residual natin yan. So this is just the normalized value of your standardized residual. Then we have this, the standard error. And then the Cook's distance is a measure of whether this point, this particular point is an influence point. No? Discuss lang natin next meeting yan. Influence point. Okay, for next meeting guys, tapusin natin lahat to. Kung pwede guys, paki-run to. Ito. Yan. Yan. Kasi hindi lang tayo dapat natatapos sa regression. Kailangan meron tayong diagnostics. Okay? So we don't just stop at saying, ito na yung model natin. Kailangan i-diagnose natin particularly the residuals. So this will now tell us how to look at the model, yung model 1 natin, and analyze if it's okay. No? And then, ito na yung guys yung explanation. No? Pakitingnan na lang to. Okay, and then we'll continue from this next meeting. And then come up with another model. Okay? I-compare natin si model 1 at saka si model 2. Alright, so thank you so much guys. Stop recording ko muna.